Have you ever wondered how black holes form? These mysterious cosmic objects are known for their intense gravity, pulling in everything that gets too close, even light can't escape. But how do black holes actually come into existence, and what makes them so powerful? Today, let's explore the science behind black hole formation and understand the incredible process that leads to their creation. To understand how black holes form, we first need to talk about stars. Stars, like our Sun, are massive spheres of gas, mainly hydrogen and helium. These stars shine because of a process called nuclear fusion happening in their cores. Fusion releases an immense amount of energy, which pushes outward and keeps the star stable, balancing out the force of gravity pulling inward. But every star has a life cycle, and it's the end of a star's life that can lead to the formation of a black hole. When a massive star, one that's at least 20 times the mass of our Sun, runs out of fuel, it faces a dramatic change. Without fuel, the star can no longer sustain nuclear fusion, and the outward pressure that balanced gravity fades away. Gravity takes over, causing the star to collapse in on itself under its own immense weight. As the star collapses, it compresses its core to an incredibly dense state. This process triggers a supernova, an explosive burst that ejects the outer layers of the star into space. What's left behind is the dense core, which keeps collapsing until it becomes a single point in space with nearly infinite density. This point is called a singularity, and it's the heart of what we know as a black hole. At the boundary of this singularity lies the event horizon, the point of no return. Once anything crosses this boundary, it's impossible for it to escape the black hole's gravitational pull, not even light. This event horizon is what gives black holes their black appearance, since no light can escape to be seen. Not all stars end up as black holes, though. Stars with lower mass will eventually become white dwarfs or neutron stars instead. White dwarfs are formed from stars that are similar in size to our Sun, while neutron stars come from stars that are more massive but not quite massive enough to form black holes. So, only the most massive stars go on to become black holes. Interestingly, black holes come in different sizes. Stellar black holes form from collapsing stars and are usually a few times the mass of the Sun. But then there are supermassive black holes, which are millions or even billions of times more massive than our Sun. These black holes are often found at the centers of galaxies, including our own Milky Way, and they have a powerful influence on the stars and planets around them. Scientists are still studying exactly how these supermassive black holes form, but some theories suggest they may grow over time by merging with other black holes and consuming nearby stars and gas. Here's a fun fact: black holes don't actually suck everything around them, as movies might make it seem. If our Sun were suddenly replaced by a black hole with the same mass, the Earth would continue orbiting it as usual, it wouldn't be pulled in. Black holes have intense gravity, but you only feel it if you get very close to the event horizon. To sum it up, black holes form from the dramatic collapse of massive stars at the end of their life cycle. When a star runs out of fuel, it collapses under its own gravity, creating a dense singularity surrounded by an event horizon. And from stellar black holes to supermassive black holes, these objects remain some of the most fascinating mysteries in our universe. The next time you look up at the night sky, remember that somewhere out there are black holes, powerful, unseen forces shaping the cosmos. If you enjoyed learning about black holes, hit that subscribe button for more science explainers. And tell us in the comments, what's the biggest space mystery you're curious about?